Yesterday it was DOS, so today I thought about showing something more modern. Perhaps play a bit with PE, portable executable format in Windows. As you may know, I have written a tutorial about PE. And today I'm going to play with sources I made for that tutorial. As for the full tutorial, I'm going to give you a link. And perhaps one day I could also make a full video version of that tutorial. But today we are just going to play a bit with some sources and files. This is one of the sources from this tutorial. A very basic one with not many macros. All the structures are just built manually, including relocations. As in the tutorial, we made a listing so we can view produced image to exact byte, view every byte. Now, what I wrote in tutorial is that when we added relocations and also this flag, dynamic base, then we allow executable to use ASLR mechanism in Windows. We should try it. Let's invoke a debugger here. As you can see, the base address here, B31000, is not the one that we included in header. We requested this default image base, but we got a different one. Windows was able to do that thanks to relocations that we provided. Oh, is text in debugger unreadable? Can I adjust that? Okay, then let me change this a bit. Is that better? Okay, I'm going to be switching to this view when I need to show something in debugger. So here you can see the address. RVA of entry point is 100. 1000. So the actual image base is B30000. Oh, here you can see this. This is our image base. Start with MZ. This is the beginning of the image. Now, what happens if we turn off this flag, dynamic base? Yeah, this time it uses default base. So even though we have relocations here, and even so Windows would like perhaps to use ASLR, unless we have this flag, it does not work. Now we can try with the flag again. And this time it is yet another address. So we get randomly chosen address for our image when we allow this with giving this flag. By setting the dynamic base flag. Now you may also know about this flag. A flag that tells Windows that relocations have been removed from the file. And again, it uses default base for 00000. It should be noted that in this case we have a contradictory information in our image. It has relocations, there is a relocation directory, not non-empty. But on the other hand, it also has this flag set, and Windows treats this flag as more important than just having a relocation directory. So when this flag is present, then even when we have dynamic base flag set, Windows is not able to relocate the image. But there is an interesting bit here. Even though Windows normally will not relocate such image, it might do it when it is forced to do it. We can say set default base to 0. Windows is not able to load any image at address 0 because it is reserved for other purposes. Forgot to turn off the debugger. And now you can see that it loaded it at base 10000. So it actually relocated the image by as little as possible from 0. And the relocations were applied because pointers to text have the right values. Yes, this is the minimal address at which Windows can load an image. Yes, you can't load at any address below. Well, by specification, PE specification, the address must be a multiple of this value of 64K. So the only possible smaller address would be 0, exact 0. But exact 0 is reserved and cannot be used as a base for image. So this demonstrated that this flag can prevent Windows from applying ASLR by telling that image has no relocations. On the other hand, when Windows really needs to relocate the image when base is 0, that Windows uses relocations anyway, and this flag does not prevent it. So as shown here, Windows then relocates minimally, not to a random base, but to this exact base first after 0 that is possible for PE to be loaded at. Now if we remove the flag, then we are going to enable ASLR again. And once more, the address is random. And another option we have not yet tried is to disable this flag and still have 0 base. Let's try it, let's see what happens. Once again, we see that only minimal relocation was applied. So no random address. Does it have anything to do with virtual physical memory? Well, with virtual memory, it's the virtual address 0 that is reserved. Now, this setup that we have here can be used to try some interesting tricks. Because we now have relocations applied to our executable. On the other hand, the address is predictable. The address is always the same. So we could use relocations in this case to, for example, hide some data or code inside relocations and then make them write this code or data into some places in image when Windows is loading it. CR3 register is a completely different layer here. Yeah, the addressing modes and how the memory is mapped. This is not very related to how relocations in PE work. This is a separate topic. Alright, let's try to add some relocation records. Currently we have this macro that makes relocations record. But we can use this snippet to make another one. Let's take a look at this. After the exit process call, we had a double word that was filled with 0, but we applied a custom relocation, additional relocation to this double word, and it has been now changed to this address. Some connection problems, bandwidth. Let me check if the stream is in good condition. Well, Twitch says that the bandwidth is okay on my side. Please try to manually set up the quality of stream and see what happens. No, relocations in 64-bit PE are exactly the same, but there is an additional type for full 64-bit relocation. But this is just a different type. When we build the table for relocations, we have type included here in high bits. 64-bit PE uses additional type. Later in the tutorial we make one for 64 bits. Here the type is customized. This one is for a double word and this one is for quad word. Ender is not with us today. I thought about making a little change here. Let it be of EAX 0. This is just so we can see it a bit better in debugger. So 0 has been relocated. Let's try applying the same relocation twice. Now it's twice the number. So as you can see, we can in fact add a single unit to a byte, increase byte by 1, because every time we apply relocation to such double word, we just increase this single byte within it. It is therefore possible to make an elaborate encryption, modify the right bytes the right number of times, and construct code or data at runtime that was not visible in the image on disk because it is hidden in relocations. Bye bye Rexsock. Okay, so for example, we can try to construct 1, 2, 3, 4 value here. First byte is we need to move back by offset 2 to relocate this byte. Not really relocate a byte, but relocate a whole double word in such way that this byte gets modified. Then this one 2 times. Another one 3 times. And the last one 4 times. Let's see how that works. Now we have 1, 2, 3, 4 here, generated by relocations. Oh, would you like me to repeat the whole process? Alright, let's go back. This is an address of this immediate in the instruction code of mov EAX 0. And we generate a relocation record for this field. Relocation is applied and the base address is 10000. So when we relocate from 0, this value of new base address is added to that 0. But this value is predictable. We saw earlier that we can make this image in such way that relocations are always applied to move from 0 to this address. So we know that the value that Windows is going to add to that 0 is exactly this one. And this has the same effect as just 1 is added to this third byte within the field. Therefore, we can make a relocation that adds 1 to a specific byte. So now, to make a value that would be a sequence of 4 bytes, this is little endian, remember? We can generate relocation shifted 2 bytes down to increase the first byte, then increase the second byte twice, then increase the third byte 3 times, and 4 times the last one. And it works as expected and reliably. So this is a possible trick to hide something within relocations, encrypt a bit of your code. I also tried a similar thing with ELF relocations in Linux, but there is a limitation there, because in ELF relocations have to respect the permissions of sections, or load time segments to be more exact. In Windows, the section may not be writable, but relocations are applied by loader earlier. In Linux, relocations are applied respecting the permissions of the section. So you cannot apply them to code that is not writable. This limits possibility of the same trick in Linux. Well, that's all for today, unless you have any additional questions. Thank you for viewing, and see you next time.